Hi everyone. We just finished chapter 3 and right now we're going to jump up to chapter 6, mainly because we're going to move to solving inequalities, which is so similar to solving equations. I thought we could go there and have a good understanding of inverse operations and how to apply them in this new topic. So this first section of chapter 6 is solving inequalities using addition and subtraction, really just the same way that we had started solving equations. I am taping this video in the classroom, which is a little bit noisy next door, so hopefully we won't have too much distraction. Okay, the goals are writing inequalities that represent a graph, looking at solutions graphed on a number line and being able to write an inequality that represents that. And then the second thing is we want to solve inequalities using addition and subtraction and then graphing that solution set on a number line. As always, this video is on Ms. Jackson Math Teacher. Let's start out with some vocabulary. First, what does it mean to solve an inequality? Well, much like solving an equation, we solve an inequality using inverse operations. So exactly the same way we solved our equations. Inverse operations. Those are those operations that we would do exactly the same on both sides of the equal sign. Unlike equations, however, the solution set is usually a range of numbers. Rather than one solution, we usually have a range of solutions, and it could even be infinite, okay? And graphing an inequality, well, that represents all possible solutions on a number line. So that's usually what we use to graph inequalities, although when you move on to Algebra 2, you'll also be graphing inequalities on the XY coordinate plane. Okay, and just like solving equations, when we check a solution, or solutions plural, we substitute, and we are looking for what? We're looking for a true statement. So we want to substitute into our original inequality to see if we obtain a true statement. If we get a false statement, we know that our solution set, or what we thought was a solution, is not correct. All right, let's just very quickly review these inequality symbols, which some people have trouble with. The main thing you always remember is the point goes to the smaller values. So I'm just going to write down here a inequality symbol. In this case, it means less than. But the point goes to the smaller value, and the big open mouth goes to the bigger value. Okay, so right here, this symbol stands for less than. So when we look at this example, it is saying x is less than 8. And it's not T-H-E-N, it's T-H-A-N, less than. Okay, next symbol is greater than. So here on our example, we have P is greater than negative 2. And the next one, we have a less than symbol here, but we also have a little line underneath it. And in our example, we have the same thing. Y is less than or equal to, that's what the line means, or equal to 0. And likewise, with this symbol here, greater than, with a line under it, we have W is greater than or equal to 10. All right, that was just a quick review since we've done this. All right, let's also review how to graph inequalities. Here, this is saying x is less than 5. It does not say x is less than or equal to 5. Therefore, when we go to the 5 on the number line, we go with an open circle to indicate to our eyes that it cannot equal 5, but it can approach 5 very, very closely. Now, all the numbers that are less than 5 are going to the left. So we would draw that with an arrow, and we can just maybe even put here x. Those are all the solutions, x. Next example, x is less than or equal to 8. Since it can be equal to 8, we will go to 8 on the number line and we will put a circle, but this time we're going to fill in that circle. And again, all of the numbers that are less than or equal to 8 are going to the left. Fourth example, x is greater than 0, not equal to 0, however. So we have to go with an open circle all the numbers that are greater than 0 are going over to the right. And why am I showing these arrows here when I'm graphing? I'm showing those arrows to show your eyes that that ray just keeps going on and on up until positive infinity. And finally, x is greater than or equal to 2. Well, if it can be equal to 2, I'm going to go to 2 on the number line. This time I have to fill in the circle because I can be equal to 2. And I'm just going to kind of graph those x values going to the right since they are greater than. All right, now how do we solve an inequality? Well, it's very similar to solving an equation. Here we have our unknown x. We always go directly to the unknown. We look what's around the unknown, and we undo those things using inverse operations. Okay, so what do we have around our x? Around our x, we have subtract 3. So that's at the bottom level. We undo subtract 3 with addition. And instead of bringing down the equal sign, we're bringing down the less than symbol. And we have to add 3 to the other side. So x comes down, opposites reduce out to 0. And we have negative 4 plus 3, that is a negative 1. In this case, we have just a blank number line. Now, how do we graph it? Well, that's kind of up to you. You can choose to put 0 and 1 and negative 1 anywhere you want to here on this graph. I'm going to randomly just choose here for 0. And I don't really want to write that dot anymore. I don't know why I did that. Okay, so I'm going to choose this for 0. Therefore, this would be 1, 2, negative 1, negative 2, negative 3, and so on and so forth. And so on and so forth is represented by these 3 dots. Dot, dot, dot. Okay, so we go to negative 1. And since our x is less than negative 1, but not equal to negative 1, we go with an open circle right on the negative 1. And all the numbers that are less than, of course, are the numbers that are going more and more and more negative. So here is all the values x less than negative 1. Example 2, we have 3 minus x is greater than 5. Well, always, we are going to go to our unknown. Go directly to our unknown. We have here negative x, and what's happening now? It looks like we're subtracting 3, but we're not subtracting 3. We are adding 3 because the sign in front of the 3 is positive. So if we want to subtract 3 out of there, getting x by itself, 3 minus 3 is 0. We have negative x coming down, and we have greater than 5 minus 3 is 2. Now look at here with this negative x. We don't want negative x, we want just x all by itself. So this is saying the numbers that are opposite of x. That negative means all the numbers that are opposite of x are greater than 2. So let's go ahead and pick any spot here for 0. I'm just going to randomly choose there, but I didn't have to. And I'm going to label my number line, dot, 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 dot. So the opposite, that means change the sign. So change the sign of all the numbers that are greater than 2, and that's our solution set. Let's just do an experiment. If I have, just choose any positive and negative numbers. And let's just try to make a little table for ourselves over here. If I have x, I'm going to look at what is the opposite of x. So let's try some negative numbers, and I'm just going to be random about what I choose here. I'm going to choose negative 5. I'm going to choose maybe negative 3, negative 2, 0, and maybe 2, 3, 5. If I look at these negative numbers here and I take the opposite of them, it's going to make them positive. Positive 5, positive 3, positive 2. Now 0 doesn't have a negative or a positive number, it's just 0. If I take the opposite of positive 2, I get negative 2, negative 3, negative 5, etc. So let's take a look at where our numbers fall here. We're looking for the opposite numbers of x, negative x I should say, that are greater than 2. Well, where are the numbers over here in our table that are greater than 2? Here's some numbers here. 3 and 5 are greater than 2. Now on this side, 2 is close to being greater than 2, but it equals 2. So we're actually looking for all of these numbers that are less than negative 2. I'm going to show that over here with an open circle. All the numbers down here that are less than negative 2 but not quite equal to negative 2 are going to result in numbers that are greater than positive 2. So this is our solution set. In the next section of this textbook, I'm going to show you how to make this much easier than using this table here. But right now I thought it was good to experiment. All right, example 3. Go to the unknown, go directly to the unknown. What's around it? We're adding 4. How do we undo add 4? We're going to subtract 4. Opposites reduce out to 0, and I have 4 minus 4 is also 0. So right here, our inequality says 0 is less than or equal to, and I'm going to spell it out, or equal to x. Well, if 0 is less than or equal to x, and I'm going to just go ahead here and pick any spot for 0, it doesn't matter. That would be negative 1, negative 2, negative 3, dot, 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 dot. So if 0 is less than or equal to all of my values of x, then we know that the values of x are greater than 0. If 0 is less than or equal to all of my values of x, then all my values of x are greater than or equal to 0. And we have one final example. Go to the unknown, go directly to the unknown. Look what's around it. We're adding 8. We're going to subtract 8 from both sides. Opposites reduce out to 0, greater than or equal to 3 minus 8 is negative 5. All right, so in English, this says negative 5 is less than or equal to y. Well, let's go to negative 5. We're going to pick any spot for negative 5. If that's negative 5, that's negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, dot, 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 dot. So if negative 5 is less than or equal to all of our values of y, and it is or equal to, so I'm going to close up that circle. If that's less than all of my values of y, then all my values of y are greater than negative 5. So all of my values of y are all these over to the right. Okay, hope this helps. Thanks for listening. Take care.